All right, this is my first coding challenge that I'm going to attempt in JavaScript using 3D rendering. I am currently working on a set of tutorials about WebGL in P5.js. I will link to those from this coding challenge's video description. But Bees and Bombs on Twitter, I highly recommend if you're interested in looking for like really geometric, algorithmic, mathematical illusion GIFs that will kind of blow your mind. Check out the Bees and Bombs Twitter feed and look at this. Oh yeah, look. Bees and Bombs is watching this right now. This is the GIF I'm going to try to recreate in P5.js using the WebGL renderer. Okay, so let's just see how this goes. I'm just going to get started. So first I'm actually going to just work in 2D because one thing that I need is just this nice, and I really need this in my life. Breathe in, breathe out. Breathe in, meditation. I'm very high-strung. I really need to work on meditation. And this is actually a nice, calming, soothing GIF. So I need something that can give me that oscillating behavior and the sine function, simple harmonic motion, the swinging of a pendulum, the plucking of a guitar string. I do have some other video tutorials about that in processing that I will also link to from this video. So first, let's just make that happen in 2D. So what I'm going to do is I am going to have a variable. I'm going to call that variable angle. And I'm going to stick, I could add angle mode degrees to think in terms of degrees, but I'm just going to stick with radians. I'm going to say angle plus equals 0.1. Then what I'm going to do, and because once I get into WebGL mode, the center, 0, 0 in WebGL renderer is the center. I'm actually just going to quickly translate to the center because I want to just do this in 2D real quick. And let's say a rect mode center. And let's draw a rectangle. So I want to draw a rectangle which position is 0, 0, and its width is some arbitrary thing like 10, and it has some height. So if I were to say let h equal 100, I'm in the wrong place. We're going to do here. Okay, so one of these days I'm going to be able to move between these. Okay, so let's add a background. That's black, and let's add a fill. That is 255. Okay. Come on. There we go. So there's that rectangle. So what I want to see it now is breathe up and down, oscillate up and down. So the sine function is a function that will give me a value between -1 and 1. If I were to graph the sine function, and the x-axis here I could think of as that angle, that's increasing over time, I would see a curve like this. And that curve is going to oscillate between +1 and -1. So I could certainly use the map function and actually probably will. I'll use the map function. The math is not that complicated, so I could take the result of the sine function as a variable value, and if that's between a range of -1 and 1, and I could map that range to between 0 and 100. Of course, I could just like multiply it by 50 and add 50, but let's use the map function. Why not? It's there in P5. So I could say h is now map sine of the angle, which has a range between -1 and 1, to between 0 and 100. And what we should see now is this. So this is the behavior. I believe this is simple harmonic motion. There's so much that you could do with this. Right? Think about layering these, all moving at different rates, offset from each other with different colors and sounds. You know, the world is your oyster now and what you could do with like simple harmonic motion. But here what I'm going to attempt to do is I'm going to attempt to try to create this. Now actually, I still think maybe I'm not ready for 3D because I think what I want to be able to know that I can do is put a bunch of these in a row, all oscillating offset. So can I make a 2D version of this first? Let's see if I can do that. So how am I going to do that? Well, I clearly need a loop. So let me say x equals 0, x is less than width, x plus equal, and let me go over by 10 pixels. And then let me draw each one of these rectangles at x. And I'm going to draw it with a width of 9 just so I can see it in between. So this. Okay, so I forgot that I translated to the center. So Please go away, terminal. So what I want to do is start x at, I'll just say x minus width divided by 2 here. Whoops, what do I have wrong? Line 13, for let x equal 0, right? Okay. So there we go. Now I have a whole sequence of these oscillating, but obviously they're all oscillating together. And if you see here, they're all oscillating slightly offset from each other. So what do I need? I need an offset. So let's make a variable called offset, set it equal to 0, and I'm going to say, I just want to, I'm going to say let A equal angle. I'm just going to break this up into multiple lines of code because I think that makes things a little simpler. So this is the same thing, but now what I'm going to do is say angle plus offset, and then that offset is going to change for each one of those. And maybe let's just try offsetting by the same amount that the angle is increasing, so they're all just one step ahead of the previous one. There we go. Now this has a totally different look to it, and it's actually like it looks like it's almost like this shape moving to the right. I mean, I don't know, I think we could start to play. I should probably hook up some sliders here, like with different values. I'm going to get different sort of things like, but is this the right idea? It's so funny because it really looks like this thing moving. But what it is, if I make these thicker, like could I have less of that? Yeah, there we go. So you can see this, it's really an optical illusion, by how I play with the size and where they're, and also like the x should start. So I need some more variables here. Let me make a variable called w, which is the width of each one of these. And I'm going to set that equal to 24. And I'm going to say w minus 2, just to give a little buffer between them. And then this is also where they start is x minus width divided by 2 plus w divided by 2. And let's have the offset just be perfect again. And we can say, there we go. So what you can see, this is all that. Now, in the bees and bombs GIF, there certainly is this sense of the center going up and down, rippling out to the outside. So I might need to think about like what angles I'm starting, where the offset is, and that sort of thing. But I think this is close enough. So let's try moving this to 3D. Okay, so a few things I want to do. First thing first, let's just add webgl, and let's just take out this translate. Dare I say, if webgl mode works the way I hope and dream it will work, I'm actually going to see the same exact thing. Right? All I did was change the renderer. I'm still drawing everything as 2D shapes. I just changed the renderer, and now I don't have to translate because by default the renderer thinks the center is the center of the canvas is 0, 0. All right, so I'm not seeing the shapes. Oops, let's just see. Let me change the background here. Yeah. Oh, whoa. First of all, look how slow this is. Crazy how slow it is. And the reason why I wasn't getting the color proper is because, well, I really shouldn't be using the rectangle function here in 3D. So let's see if we can figure out, let's try to make this a little better right now. First of all, let me put boxes in this spot. So what I'm going to do is I'm going to say push, I'm going to add push, and I'm going to add pop. And what I'm going to do is I'm going to just translate by the x value, 0, 0. And instead of drawing a rectangle, I'm going to draw a box of that size. So let's see what I get. Okay. Oh, and incidentally, now what I need to do is I need to translate x minus width divided by 2. So these are all boxes. These are 3D boxes. You can't see that they're 3D because I'm just seeing them from the side, but you'll have to bear with me here. Just to prove that they're 3D, what might be worth doing is just saying something like rotate x by that angle. So that angle that's affecting the side. So we can see that they're there. I'm going to leave that in there just so that we can see this like slow rotation of the scene. And I'll even slow it down by like a quarter. So what I want to do now is, let's see if I can, how do I affect the heights only of those boxes? So the box has a width, a height, and a depth. So I want, whoops, the depth I'm just going to have BW as well. So the width and the depth, which is along the z-axis, and the h is the height. So let's try doing that. There we go. Now they're spinning. Whoa, look at this. I think I'm getting somewhere. Wow, this is kind of crazy looking. Oh my goodness. Let me take out that spinning. Let me move the whole thing down a little bit. And let me zoom out from it a little bit. So I'm going to translate like everything down like 25 pixels and out like 50 pixels. So we're kind of like zoomed away from it. I want to see it from above a little bit. So if I translate it down even further, I guess I need to think about maybe the camera, or I could like sort of like rotate everything by like a slight amount. Like so I want to rotate along the x-axis by like 45 degrees or something. Oh no, I want to just say rotate x. And I want to do it the other direction. There we go. So I just wanted to get some view on it that somewhat resembles, sorry, I lost this particular view. Now one thing you'll notice, have you ever played the video game Qbert? Well, what this looks like to me, I believe, is something called isometric perspective. Or no. Yeah, or orthographic perspective. Let's look at the P5JS reference for a second. Reference. Perspective, yeah, perspective. Perspective is a function that kind of says like, hey, this is where this is what the camera can see. This is its view of the world. And actually what I want is this function ortho, which sets up, now there's not a lot of documentation here, but it sets up, so let me see if I can like orthographic perspective. Let me do an image search. So this is perfect. So you can see this is a really nice image here to kind of demonstrate the difference. Perspective projection has this realistic view of sort of distance and of all of this idea of like perspective of drawing, if you were trying to learn to draw in perspective of how the lines come together to a point. Whereas orthographic projection, so perspective is the wrong word. I'm saying orthographic perspective, that's not right. The idea here is the projection creates this highly uniform look. And the video game Qbert is probably the most famous sort of example of this kind of orthographic projection. So let's add orthographic projection. So I can give it like a clipping plane or a sort of, it's called a frustrum, like the bounding box of what I want to be able to see with orthographic projection or isometric projection. But I think by default, if I just say ortho, it's going to change. And let me hit refresh. And whoops, let me put, okay, so yeah, so you can see now it looks very flat. Now I need to be able to start to see the different sides of different colors. So let me see if I can add maybe at least some directional lighting, maybe. Let's see if I can just add some lighting from the top. Let me just say directional light, 255. And let me add the light from the top. So 255, 255, 255. And then I want the light to point down, which is 0, -1, comma 0. So let's see if this gives us at least some shading. And what if do I probably still have fill in here? Ah, right. So I need to, fill is going to take over. I need to just give it ambient material. Ambient material will allow the box to be affected by the light. There we go. And I can make the, oops, and I want the light to be white. And maybe I can make the background black. Yeah, so I'm not really getting a lot of nuance here in terms of, but let's make the box's width a little less, so there's some space. Okay, and I want to be able to look at it now. Maybe I should just give it ambient light. I could give the different sides. I'm lost now. All right. So how come I am not? Let me try rotating. How can I see the tops? How can I see this shape? I need to figure this out. Oh, ambient light, by the way. So I don't want to use ambient light. I could try a point light. I'm thinking, maybe I'm going to get a suggestion from the chat. I just want to, let me give it normal material. So normal material is a useful material for debugging because it just gives it an RGB colors to all the different vertices of the shape based on their X, Y, and Z values. So let me give it normal material. All right, so actually, I think this is doing what I wanted to do now. I'm seeing the orthographic projection, and the normal material is giving me RGB colors for all the vertices, but let me make the background 100 just so I can really see that. There we go. So this is actually, I'm now looking at the correct thing, but I'm not actually looking at isometric view. Here's the thing though, I'm gonna leave this like this right now. Let's try to nest this loop, and let's have a bunch of these. So what I'm gonna do now is also add an inner loop. Let's add an outer loop. Let's add an outer loop for y. And what I'm going to do with y now is translate y minus height divided by 2. Okay? And let's make the depth also a little bit smaller just to have some spacing there. So, okay, x is not defined where? Oh, this has to be y. Thank you. Okay. All right, now, is this doing what I want it to do? Is it doing what I want it to do and just a weird sort of view of it? So let's try to start altering. I want to see what's going on here a little bit. So what I'm going to do actually is rotate x by that angle. Whoa, I've really freaked it out. Let me take this out. Let me make this just fixed. So what is going on? For every x, for every y, draw a little box. Oh, they're all just right next to each other in a line. Oh, because I don't want to go along the y. People are probably talking about, I need to use z. Of course, z. Of course, the z plane is what is allowing me to create this grid of them. Y is what's moving up and down. So, I apologize for this. So I'm actually going to do z. I'll just leave height. I'm going to change the variable to z though, just because I feel like it's going to be confusing. And now, yeah, we see now I have this grid of them, and I'm kind of spinning around it in a weird sort of way. And what I'm going to do here is, and I actually don't need this offset to subtract backwards, I don't think. Oh, actually, no, that would be good to keep that in there. Okay, what I want to do now, hold on everybody, is let me take this out. Okay, now there's this plane of them. Let me put h back in. And interestingly enough, what's going on here? Sine, angle equals angle plus offset. So I want the offset to happen right now just per row. Okay, so I see this whole row going up and down. All right, now here's the thing. I need to be able to look at this. I probably should have done this before. I really should have done this before. But if I look at isometric perspective, actually to see isometric perspective, what I need to do is first rotate by 45 degrees about the vertical axis, which is x. So I'm going to, let's get rid of this translate, which I think is, actually we're going to leave that in there. I don't need rect mode center. I'm going to rotate x minus a quarter pi, which is 45 degrees. Let's see what that looks like. All right. That's kind of interesting. What's going on here? Now, I'm kind of looking at it from this weird like top view. I want to turn it. So the next thing I want to do is rotate by y of, and let's look at this. Arc sine or arc tan. So I could do one of these. So I'm going to do arc tan of 1 divided by the square root of 2. And I should make this a constant somewhere that I save. Let's call this magic angle. And say, let's call this, I'm just going to call this MA for magic angle. MA equals A tan of square root of 1 divided by square root of 2. So let's now rotate y by that. Thank you, Alka, for having suggested this. There we go. Ooh. Okay, we're in good shape here. Look, I'm seeing this now. Here's the thing. I've got a clipping plane issue. Like I'm not actually able to see the whole thing. So let's deal with that. With ortho, I can say this is the range of what I want to be able to see. So I want to see between negative 200 and 200, between negative 200 and 200 on the y, and then I just want to be able to see like a lot along the z. Okay, that's everything. And maybe I should zoom out a little bit, just so it's a little further away from me. Hold on, let's get rid of this translate. And let's say 0 to 500. There we go. I think then, all right. Oh, it's like I've turned it over also. Boy, what a mess. So maybe this should be 200 to negative 200. There we go. Ah, kind of getting somewhere. Look at this. Kind of getting somewhere. Okay. Now I need to deal with my clipping planes. And I actually think it might be getting clipped in all, whoops. There we go. I want to look at it from further away, so I'm going to create that. So that was too much. 300, let's try 300. And boy, I could make these variables would really help. There we go. Okay, so I'm seeing this thing now. It's kind of like a little bit off weirdly. Okay, it's a little bit off weirdly. And so what am I missing? Does this just need to be, is that the z that's getting clipped? Yeah. Okay, so now I see the whole thing. I see the whole shape. Now what I need to do is figure out the offset. And what I think I could do, if I think about this, is the offset is not a value related to along the x or along the y, but how far it is from the center. So what if I were to come back here and inside my loop have some kind of distance value, be the distance between x and z and not 0, 0, but width divided by 2 and height divided by 2. That's how far they are. I feel like I should actually have just translated this whole thing offset. It would have made it easier, but because I have all this like offsetting. So that's the distance. And instead of having this offset like increase, what if I just say offset equals map that distance? Now what's the range? I probably should figure out what the maximum distance is. The maximum distance is max d is going to be the distance between the center and 200, 200 really. Right? That's kind of like the maximum distance. So d has a range between 0 and max d. And I want that offset, I'm just going to make up something between -1 and 1. Like I want an angular offset for each of those. Now let's look at this. Ooh, it's so slow, but this is the right idea, right? So let's make this, let's try to make this run a little faster, boy P5. So there's probably a lot of optimization that needs to be done because we certainly can do this in WebGL. I'm sure we're all going to remake this. So a couple things I want to do. One is, let me make this, let me make them bigger. What is the slowdown? Okay, that's a little bit better. Now, I want this, what it's mapping to in terms of the height to be a lot taller. Yeah, so I need to do some work with like pre-saving all the geometry, but then I'm getting, Alka's making a good suggestion. Okay, so I have to go though, this challenge is over. Let's have the offset be more, twice as much. There we go. Hey, look at this. Pretty close, right? Pretty close. So what have I not done? One is I really need to deal with optimizing this. One reason it's running so slow, I think, is actually it's kind of unhappy with having these floating point numbers for the height of the box. So I think if I change this to floor the values, but I am getting some weird artifacts here. And that's actually, if we look at the bees and bombs, you'll see that it doesn't actually go to 0. It goes between some set of values. So it goes between maybe like 100 and 300. Let's try that. Whoops. There we go. So that is much more like, now could I zoom out on this more? So one way I could do that is by translating. I don't know if this makes the most sense to do. Let me zoom out a little bit. No, you know what I need to do is just change the, I think I need to be more thoughtful about the orthographic view. Okay, so I zoomed out a little bit and make more, let me make more cubes now. So let me change this back to like 24. There we go. How am I doing? So this is moving faster, and that offset is even more. So let me map the offset, and actually, yeah, -3. Let me just. I mean, I probably should be thoughtful about this and have that offset be like, you know, some actual like angle. Oh, but that's half pi. Actually, let me just have it between -pi and pi. Let's try that. There we go. This is starting to look good. And now, okay, and now let me have it go a little bit faster. Here's the thing, here's what's missing, and I'm going to leave as a challenge for you, the viewer. Number one is, I've got the perspective slightly off here. Something's slightly wrong, right? I don't have my angle exactly right. Right? Why is there this weird kind of like diagonal there? It's also in reverse. Everyone's telling me it's in reverse, so this has got to be an easy way to fix that. Oh yeah. Ooh, that's kind of nice. It's a little bit too fast. Okay, I didn't get all the way there, but I got pretty close. And so the challenge for you, the viewer, is to fix my mistakes. Something about the perspective is off. I probably need to think about, you know, the speed, and I might like to color or use lighting to make it more beautiful. What other types of 3D shapes? Oh, rotate X after rotate Y. Did I just do this in the wrong order? Whoa, that's kind of cool. something different. Okay, I gotta go. Thanks for watching this coding challenge, and I'll see you all later.